We're going to look at change of basis matrices. Let's first look at the following example. Let P1 denote the vector space of linear polynomials in X with real coefficients. That is, P1 consists of all the vectors of the form ax plus b, where a and b are real numbers. And suppose that we are given two ordered bases for P1. Gamma is x minus 1, x plus 1, and omega is 1, 2x plus 1. Suppose that we have a vector u in P1 such that the tuple representation of u with respect to gamma is 1 minus 1. What is the tuple representation of u with respect to omega? So to answer this question, we first need to figure out what u is from this information here, and once we know what u is, we write it as a linear combination of the vectors in omega, and from there we'll get the tuple representation. So u is going to be 1 times the first vector in gamma plus minus 1 times the second vector in gamma, and that gives us x minus 1 minus x minus 1, and so that is minus 2. And now it's easy to see that minus 2 is simply minus 2 times the first vector in omega plus 0 times the second vector in omega. And so the tuple representation of u with respect to omega is going to be minus 2, 0. So we have done this work for one particular vector in P1. What we'll see is the following. There's a 2 by 2 matrix A such that the tuple representation of u with respect to omega is given by A times the tuple representation of u with respect to gamma. What this is saying is, once we have found this matrix A, converting tuple representations with respect to gamma to tuple representations with respect to omega is just a matrix multiplication. So how do we do this? In fact, we have already done all the hard work when we looked at matrix representation of linear transformation. So let's first recall the following. Suppose that T is a linear transformation from V to W, where V and W are vector spaces, and gamma is an ordered basis for V, and omega is an ordered basis for W. Then what we have seen is that there exists a matrix A such that the tuple representation of T of U with respect to omega is given by A times the tuple representation of U with respect to gamma. And we denoted this matrix A by this. And this is true for all U in V. So suppose that V and W are the same vector space, and T is the identity linear transformation, that is, the transformation that takes any vector U to U itself. And then what do we have? What we'll have is T of U becomes just U, so the tuple representation of U with respect to omega is given by this. And this is precisely what we wanted here. So this matrix here has a name. It's called the change of basis matrix from gamma to omega. So we'll now end with an example. Suppose that the vector space we're looking at is R2, and we're given the following ordered basis. What is the change of basis matrix from gamma to omega? What we need to do is, we need to write each of the vectors in gamma as a linear combination of vectors in omega. So the first vector in gamma, 2, 0, can be written as 1 times the first vector in omega plus minus 1 times the second vector in omega. And one can check that this is indeed the case. And the second vector of gamma can be written as 2 times the first vector of omega plus 1 times the second vector of omega. And so the change of basis matrix from gamma to omega is going to be given by, so the first column will have these numbers, and the second column will have these numbers.